Good morning, David.
So Rob sends his apologies. He can't make it, but he's at an economics conference and he's pitching the idea of trying to come up with some kind of fundamental set of simulations, and he's getting positive feedback. So that's pretty interesting.
Sounds good. Your audio is really choppy, David. I don't know if there's much you can do.
Yes. That should be better.
Yeah.
Okay. Did you manage to get into the Santa Fe Institute thing?
I've sent out my application. I expect to hear back by end of February, they said, or early March.
So are you joining a workshop that's already happening, or are you suggesting a new workshop?
No, this is a workshop that's already happening. It happens every year. I guess it didn't happen since 2019 because of COVID, but now they're, I guess, restarting it. The only thing is, I think I made a mistake because I thought it was a 2-week workshop. It's actually a 1-month workshop. So now I have to see if I can get enough time off work to actually do that. But yeah, I'll wait to see what happens. If I get in, then I'll deal with it then.
And you'll physically go down there for a month? That'd be so cool.
Yeah, they put you in dorms, and and I think the talks and everything happens in 2 different places, one of it being the Santa Fe Institute.
Nice. I've never been there. But
you're going to go. Oh.
No, I don't know yet. I applied for a summer school. It's a competitive thing, so I had to give references and write a statement of research interest. So I'll hear back end of February.
Yeah, I applied a couple of years ago. I didn't get it.
Yeah, I think it's really hard to get it. I don't know. I guess lots of people are interested. What is your interest in the Santa Fe Institute?
I mean, I love everything that comes out of there pretty much. I mean, the whole emergence thing, I feel like that's exactly where my interest in research is. Like, how do we look at things from a top-down view rather than trying to come bottom up at everything?
Yeah, same. I feel the same. Seems like a special place.
Welcome, Sam.
Yeah, well, I hope you get it.
I hope so too. But yesterday I heard my boss gave his notice. So at least for the near future, I'll have to manage like a dozen people that used to be my coworkers. So it's gonna be I hope that I don't get so busy that I can't do anything else anymore.
Yeah. Do you have things in place for your application?
Sorry, say again.
Do you have things in place for your application?
Yeah, I've already submitted it.
Oh, you have? Okay, great.
Yeah.
Well, then it's just waiting. You don't hear until
end of February.
Oh, actually, February, I guess. Yeah. Okay.
Yeah.
Well, I'll have my fingers crossed for you.
Thank you.
I just wanted to welcome Sam. Welcome. How are you?
Thank you. This is the Alt Deep group, right? This is my first time joining in. Okay.
Yeah. So that's great. So we've been on this track for quite a while now. So you're kind of coming in midstream, which we're very happy to have you, and you're very welcome. It might be easier if you just give us a little bit of background, and we'll happily give a relative respective background, just so that we get to know you a little bit.
Sure. I guess I know about the Alt Deep stuff because I go to the ProbProg meetings, the probabilistic programming and causal inference stuff.
Mm-hmm.
I met some people at the ProbProg conference earlier, I guess last year, and they told me about the group and it sounded fun, and so here I am. I'm a grad student at UT Austin, and I saw this meeting. Wittgenstein was cool. I like the whole language game stuff. I did a little bit of philosophy back in undergrad, and so I thought I'd jump in.
Oh, that sounds great.
Cool. Who's your supervisor in UT Austin?
Sorat Chowdhury is my supervisor.
Okay, I've heard of him. Yeah. I know Scott Aronson quite well, I guess.
Of course.
But he's
Okay. So, Brian, do you want to give a quick background?
Yeah, sure. So my background is in physics. I did my PhD in physics about, 8 years ago now. So mostly experimental physics, but Yeah, it's kind of hard to explain. I've jumped around a lot. So right now I'm a machine learning scientist at AMI, Alberta Machine Intelligence Institute. So I've done stuff in like different industries, oil and gas to advertising to biology and all sorts of things. So yeah, I like to jump around a lot, which is sort of the what attracts me to this particular meetup, because we just talk about random things that comes up during the meetings. You won't be able to put a title. Maybe in the spirit of Wittgenstein, you won't be able to generalize to what we are actually trying to accomplish here. Just sort of, yeah. So I'm just here because I'm interested in talking about random things. So this one definitely has more philosophical themes compared to the probabilistic programming, where I guess those guys are trying to actually do stuff and learn more tangible skills. But here we just chat about interesting stuff. But welcome to the group. It's great to have new people.
Yeah. And Rose, do you want to give a quick?
Yeah, similar. So I've bounced around a lot. My background initially in computer science, and then I became really interested in Chinese medicine, and I was an acupuncturist for a long time, and through that became really interested in Eastern philosophy. And then just through working in the healthcare system and sort of watching what was happening, kind of coming back to technology and could we use technology to try and help us see where we're getting it wrong in medicine. And then through that kind of got into machine learning. And I think through Robert's class was how I met these guys. And just always trying to come at problems both from like a top-down and bottom-up perspective, and trying to see if we can see things in a new light. And so this meetup has been great because I think we all have very different perspectives, and I always learn a lot from these guys.
And I'm David. I have a long history in computer graphics and supercomputing. Worked in many different fields, including virtual reality, and over the last decade or so, I've been going very deeply into trying to create sophisticated agent-based intelligence. So I work in multi-agent simulation. I built a system called Fluid, which is a multi-agent simulator that can simulate how agents live in buildings, and that's being used by architects to essentially determine how sociable buildings are based on how the agents move and live in the buildings. And I'm very interested in this material, very interested in Haskell and in category theory and in programming in that way, and philosophy in general. So welcome. So last week we kind of covered the early Wittgenstein, and we were talking about the distinction between sense and nonsense and so on. And the various different interpretations are different. I'm very much a dual process person. Are you familiar with dual process, Sam? System 1, System 2, Daniel Kahneman.
Right. Okay,
Kahneman,
that is
Tversky,
somewhat familiar to me.
theory. Yeah. So that's called the dual system model. And I often try and characterize the philosophical readings that we do in terms of that. But yeah, so Sam, why don't you share a little bit about what your understanding, because this is our first kind of go at Wittgenstein, so you're the most experienced person here. What's your, have you read Carr's Finite and Infinite Games by any chance?
I have not. What is that?
And Payam, do you want to describe Finite and Infinite Games?
No, I think you read it more recently. I'll let you do that. It's hard for me to describe it. It's a strange book.
It's a strange book. So yeah, so I think it's related to what Wittgenstein is talking about with the language play, right? The idea that we can construct predicates or testable conditions in language, and they define the boundaries of games that we play, things like that. So Yeah, I'm not quite sure how we can kind of dive into this, but does anyone want to kind of take the lead on this one? I did read the material. I kind of get it. I have an interpretation which is very much my own, but if there are other existing interpretations, I'd be happy to listen to others first, or I can give my own. It really doesn't.
Yeah, I can say a little bit. So so I've sort of copied and pasted a bunch of passages that. So I was struggling with the second bit, the later Wittgenstein. So the earlier one I understood, and I understand why he switched from it. I think that's probably many philosophers do this. Like when they're younger, they're like super strict, logical, and they want to solve everything, and then they realize that's not possible. So that I understood. The second part is sort of going from. Maybe that's in the spirit of what he's advocating for, that he just keeps going from one thing to another. Some of it I wildly agree with, and some of them are wildly I disagree with, and I don't see the connection. So there's lots of, so let me try to give you some examples. Like, so first of all, so I come from a physical science background, so I found so he seems to be very, are you guys familiar with Ernst Mach, like his ideas in philosophy of science? So Mach is the same guy who came up with the Mach number, is named after him. But basically, he disagreed with coming up with theories based on the data. So he thought science should be all about tabulating as detailed as possible all the data you can on a given system and just describe the data, and that's science. And you should refrain from coming up with theories, trying to generalize and connect things together, and that's not scientific. And it seems like that's basically what Wittgenstein is also saying, but not for science, but for philosophy, that he's saying you should not try to generalize. You should just focus on particular cases and just describe all using normal language, whatever different aspects of it. And he calls it therapy. So I don't know if I agree with this. I feel myself like really disagreeing with this, because I feel like the whole point of the philosophy is the generalization. Like beyond it is, as he calls it, his language game, which might be fun, but it's completely not very useful.
What was Mach's rationale for doing this? Like, why did he think it was a bad idea to make general theories, and that one should only look at what data set instead of trying to construct generalizations based on that?
Yeah, at the time he did it, I think it was maybe justified, because lots of people like came up with these elaborate scaffoldings of things that were never seen. Like think string theory in the modern day, right? Like you can sit down and come up with a bunch of concept and put it together and make it consistent and write a story. So I think he was trying to avoid that. Like if it's not justified, like to assume that there is things called strings and nobody has seen it, nobody knows about it. It's basically what saying it's not justified to just come up with these entities and build everything around it.
So it's Occam's razor, but like more extreme.
Basically, okay. But maybe it was very defeatist, right? Like it's saying that we can see like in case of like Boltzmann, like he did the same thing for atoms, but then atoms later were seen, so you could actually see them now. But at the time he came up with them, nobody could see, and there was no reason to think at some point we'll be able to see it, right? So his ideas were like really strongly opposed, and I mean he killed himself because of it, partially. Yeah, I think it's a common debate, but just it feels really extreme to say that you should not generalize. And from what I understood from the reading, Wittgenstein was not saying that about science. So he's totally fine. He was just saying the scientific method is not applicable to philosophy. And for philosophy, we should refrain from trying to generalize using language.
So I think that's a really great point to bring in, is that he's not saying you can't do it for some things. And this is where it links back to what we discussed last week. Like when we're talking scientifically and we're building something from the ground up, we can sort of say sense and nonsense within that framework. And it's not that nonsense doesn't exist, but we really shouldn't be talking about it because we don't have the rules for it. And so I think he just comes to a point where I think we start off thinking, well, we can build everything from the ground up. But then what happens is when we come to defining things, then suddenly we find that the frames we've put around things aren't as strong as we thought they were, and that we have a whole bunch of unknowns that we didn't think about when we were generalizing. And we thought we could generalize when we couldn't, right? And so, later he talks about the colors and, you would think something like yellow or red or whatever is easy to define, but it's really not, right? It's this idea of the spectrum. And so all you can do is kind of look at how things are used in a particular situation and talk about that. Once you come to trying to generalize that, and start, I guess the rules part of it is what's really important. When you then try and build rules around that, your rules are going to be wrong.
I guess the rules always come after the fact, right? You have the intuitions first about the way things are. And then when pressed, when trying to defend yourself or something, you come up with rationalizations for why these follow some sort of orderly system. But the point is that the orderly system comes after the fact. You don't actually think that way. It's just a way of trying to organize yourself from what you already think.
It's interesting that you say that, because I think a lot of people don't think that's the case, right? So that almost leads to, is there nothing objectively out there, right? Is everything just an interpretation? Like, are there no rules?
His example is really interesting. So I don't know if I buy that. Like he also makes the same mistake of extrapolating from one example to generalizing that there are no rules. So I think he's also violating his own rule by coming up with a rule about rules. But anyways, he gives his example.
In the Tractatus as well, though. So,
yeah. I guess it's part of the language games, right? It's like he talks about series, right? Like if I give you a series 1, 2, 3, and I ask you to continue, most people would say 4 and would think that they're following the pattern. But obviously there's infinite number of rules that could give you infinite number of ways to continue a series in a coherent way. And then he uses that as an example of saying, okay, see, the generalization doesn't work here because every possible, there are infinite number of generalization here, so there are no rules. And somehow as humans, we are pre-wired, maybe through society or culture or whatever, that we tend to continue sequences in a similar way. If you give it to different people, they would come up with similar next numbers in the sequence. And I think Melanie Mitchell of the San Jose Institute and who's the guy who wrote the Gödel Escher-Bach book,
Hofstadter, no?
Hofstadter, yeah. So his whole research was focused on this, right? Like how do people like generalize rules from previous examples? And it seems like humans do it in a coherent, somewhat consistent way, and we don't know why we pick the ones that we do. There's some evolutionary reasons, but anyways, I feel it's such a strong conclusion to draw from like such a small set of rules. I guess my intuition is that language is something we built. So there is an outside world, and there could very well be lots of very general, very well-formed rules. We just maybe it's hard for us to access, but just to say that you can't generalize because you can't in these cases is kind of ridiculous.
And you can look at this kind of.
Go ahead.
I was thinking you could look at this kind of empirically, right? The success of the current, I guess, natural language models, which don't have any kind of rules, right? That they just learn unstructured associations and they work pretty well. All the old stuff that tried to learn rigid rules about how things worked and used the whole structure of language that we understood at the time didn't work at all. So just empirically, the Wittgenstein like throughout the rules approach seems to work much better than trying to figure out what the rules are.
There's two different things, right? There is rules about the language, and then there's rules about the universe, right? I'm just saying those are separate things. Like it might be very well true that there are some rules in the language that I guess these language models learn, but language is something, it's a very, very small part of the world. So just, it doesn't make sense to make language supreme above everything and then try to say that you can't explain everything through language. I mean, it's not really surprising that you can't describe everything through some language that humans came up with, right?
There are very hard limits to what language can even express, right? Mm-hmm. So
isn't that just his point, though?
Yes.
Yeah, but then he gives up. He says, okay, then there's nothing we can do. I would just say maybe you better come up with a better language. And I guess, I mean, maybe his earlier work was an attempt at that, to come up with logic that goes beyond words, but yeah, I don't know.
Welcome, Robert.
Hi, Rob.
Yeah.
Hello. I'm sorry I didn't do the reading.
No worries.
So
How are you
I think
doing?
that, how are you doing? Are you surviving?
Yeah. Yeah. Very lots of things happen and a lot of things change, and everything they say about not getting enough sleep is true.
Indeed.
Nobody can explain that to you in advance. No matter how many times you've heard it, there's nothing like the reality of us.
I mean, yeah. I don't want to derail the conversation, but yeah, it's been a trip. Sorry, Sam. I'm Robert. We haven't met, but I just had a baby and things are crazy. So that's what we're talking
I see.
about.
Robert is the founder of Alt. Yeah, so
basics.
so what I get from this is that exactly as you say, Sam, is that Wittgenstein is actually foreshadowing machine learning, right? And the idea that to move away from unlabeled models where we just have things that are outside of language and we can organize these things and expose them to data, and they can learn something that is also not language from this data and then express back to us in a non-linguistic form, in the form of a picture or a graph or a number, what it has been learned from the data outside of language. So I still think there's language constructs involved in forming the layer structure that we're going to pass the data through. So I do think we need to have a model. But I think that what Wittgenstein is getting at is this whole thing about the inability for explanations to be sufficient, right? This is Gödel's theorem, where language has hard limits and you run out of steam when you get to fundamental assumptions. And it's very interesting that Pearl, in his recent conversation with, what's his name? Wolfram. He really draws a fundamental distinction between labeled and unlabeled nodes, right? Labeled nodes are constructs of language, right? We choose to construct causal graphs with name nodes, which have inherent kind of human knowledge embedded in them. Whereas in a machine learning framework, we don't, right? We just have layers of nameless neurons that can essentially learn something. We don't know what, because we can't express it in language. They learn something from the data, and this non-linguistic system is able to give us better predictions, and we're able to construct the language. So I think that that's one of the kind of takeaways I got from that. And we're very uncomfortable with this. We don't like the idea that language can't express what, a 90 billion parameter language model can represent, right? We can't draw that into language. We can't compress it into something we can fit in our heads and understand. And so what Wittgenstein is saying, I think, is we need to accept the limits of our own ability to construct things in language and what those constructs can actually represent. But underneath that is a far more powerful non-linguistic system that is actually the interesting part, perhaps. I don't know. But Payam, did you have some more examples that we could chew on there? Or?
Yeah, no, first of all, I totally, I'm on board with what you just said. I don't know if I agree with his conclusion that we should stick to fixing language, but I totally like the idea that there could be a bigger world beyond language that we can't put into the language, because maybe, I mean, you can even like look at current cultures, right? There are like places where there is no word for snow, for example, because they've never seen it. And obviously, if you give them pictures of snow, they'll have to come up with a different story because they just don't have the word to construct it. But if you have a picture with pixels, obviously all the information is there. You don't really need a word for it. It's just the way it is. And that's, I guess, what Wittgenstein is saying. Look at the picture. Don't try to make up a story based on the words that maybe they call it white sand or something. I don't know, which might make sense, right? It's sort of, but maybe you don't need it. But anyways,
but
yeah,
even
I mean,
the picture is a representation, right? Like when we're saying, especially just talking in terms of machine learning, a picture is grasping some piece of reality in a particular form, right? Like there are levels of abstraction even within that.
Yeah,
like, depending
absolutely.
on what framework you're using to look at it. And so how do you determine what level of abstraction you should be using to talk about anything?
Feel better, just go out of your body. Mm-hmm.
So for me, the answer to that question actually lies in neural anatomy, right? This is where I get into the models of mind. So we have the very kind of high level simple models like the Kahneman Tversky kind of system 1, system 2, and then we get into Barbara Tversky's kind of maps, you know, the map cells and all of these different neural structures. So where I go with this isn't to just kind of throw language out the window, it's to try and use language to essentially construct a meta representation of these nameless neurons and nameless systems or unlabeled systems at a higher level, and then try and break down the various different constructs into the mental anatomy underneath. But that's just my approach. So if we consider the existence of grid cells and place cells, which is relatively well documented, and how we map pictorial information into these neural structures, I think we can talk about these things in language usefully. We can't like say what it means when we interpret a picture, but we can talk about the systems that are doing that work. So I agree with Payam that we shouldn't just kind of throw language away, but we should respect that it has limits. And it has, and this is why I really like Carr's stuff, because I think he very, very clearly kind of navigates language to be, or formal language, or predicates, if you will, or category theory, or whatever you want to call it. His predicates are all about boundary conditions, right? Testable conditions where we can test inside or outside. So in a reinforcement learning scenario, if the agent hits the wall, it dies, right? Because there is a rule, a testable predicate that says, are you intersecting with a wall? If that testable condition, which is constructed in language, in fact, holds true, then we take an action, an exogenous action against that agent, and it essentially learns through some kind of rebirth bias in its updated weights, that testable condition is a bad one. But we don't have any really good language for when the agent isn't hitting walls and is just wandering around, right? We don't have testable conditions in that scenario, and essentially the agent is in this free state where none of the testable conditions are essentially intersecting with its behavior. So it's just wandering around on weights that in unlabeled nodes, and we don't really know or care what it's doing because we can't represent it in language, perhaps.
So even language, if we take language out of it, and we just think in terms of objects that we're not even giving necessarily names to, like when we're looking at something, we don't sort of think, oh, immediately it doesn't sort of become, there's a tree, there's a car, there's a whatever, right? Like you're just looking at the entire image. And there's something about the a priori structures that we have programmed, some of which maybe are innate, but I don't think they're all innate. I think we learn them through our education and our experience, right? And so those, the objects you're talking about, you almost need to start off with, well, this is the model I'm using right now for this particular situation. And here are the things that are allowed within that model.
I think this is probably like, tell me if you don't think this makes sense, but I feel like a lot of these artifacts that we make in language, in whatever our models and everything, is just a way of negotiating our shortcomings as with having limited memory, limited intelligence, limited time. So it's a shortcut. It's like, I guess in information theory, they call it the bottleneck, right? Like you have to compress things in a way that you can quickly and reliably make decisions based off of. And when you compress, you throw away stuff. So maybe, as Rose was saying, you learn what to throw away in general, and that works most of the time. But sometimes it could fail catastrophically, especially in all these huge models trying to affect billions of people. So yeah, so I think there are like, maybe Sam would know this. I guess there's lots of probably, I think, I don't know the names of the theorems, but there are theorems basically about representation and compression, that there is no like universal way to compress a signal to get at its essence separate from what you want. Like there is no way to compress a signal and keeping all the things that you might find useful in the future. You can compress it to preserve something for a specific goal or a specific task. So you can like have a neural network, you put in your images, and the last layer is meant to classify things. But if you later decide you don't want to classify things, you want to do something else, then you need to start the whole process again, because what you've kept is only useful for classification. You've thrown away possibly very useful stuff that you need now. So basically, there is no universal compression or representation that keeps the essence of everything and gets you what you need. So I think the whole, I guess, intelligence is trying to find what is the right level of compression for what, and what are those, like even objects, there are no objects, right? Like objects is in general is a construct that we come up with so that you don't have to keep track of all the pixels in your visual field at all times. So yeah.
One way of thinking about language might be as a way to predict behavior, right? If certain sounds are heard, you can see people doing certain things afterwards, or certain other sounds are more acceptable to say in the same context.
Sure.
So in the same context as you were saying, like everything that you observe has to be for some end, because that allows you to throw out stuff that's not useful towards that end. And in the case of language, it's about interacting with other people. And so we are able to understand what people are saying because it is useful to us, because it allows us to interact with them in ways that help us, right?
And influence them as well, right? And make them do what you want them to do.
You guys ever see that? I think I shared it before. A presentation by Emily Bend. Is it Bender or Blender? I'll say Bender.
No, Bender from Futurama.
Let's see if I can find it. But she has this.
Is this the category theory, the subway map thing?
No, this was. She wrote that paper on like stochastic parrots with Tim Ngebru. She was a co-author of that. But she has this in another paper. She has this. Let's see if I can find it. This really interesting example of like on what can be expressed with big language models and you know, with relation to agents that are reasoning about the world. And let me just continue talking. I'll find it. I can share it. It's actually really interesting. Very germane to what we're talking about. But the idea is like, yeah, to Sam's point that it's easy to kind of create a big language model that can like say something coherent in response to something that you just said, and something that's grammatically correct and acceptable, and even probable that something might reply to a question that way. But once you start evaluating its responses in terms of utility to decision making in the world to the asker, then the grades go way down. But I'll see if I can find it. It's actually pretty interesting example.
Do you work with language models?
When we talk about,
Go ahead.
I do not. No.
I guess what I was going to say is with human reasoning, it feels like we pick a model on the fly, right? We make a conscious decision like, oh, in this situation, I'm going to use this mental model to think about and communicate about this particular thing. And you might even change that as time goes on. Whereas with machine learning, we don't really do that, right? We sort of just pick a model at the beginning and then stick with that model no matter what. We don't have a way to sort of say, oh, this isn't really working in this situation. And the best we do is kind of ensemble and get a lowest common denominator, but we don't have a way to say, oh, this is appropriate here, whereas in actual fact, in this situation, I should be using an entirely different model.
I think there are four different things, right? Sort of normal language that we use that's not scientific is not meant to be exact. It's meant to sort of portray vague things. Well, the whole point of the machine learning world, as far as I've seen, is to try and ape science, right? To try and answer questions and get at testable kind of things you can predict. And so because they come from these two different perspectives, it's natural that you'd have sort of the opposite view. In one hand, like having a model in mind the entire time, on the other hand, wanting to put off making a model applicable until you possibly can. Does that make any sense?
Mm-hmm. Yeah.
And I mean, and Rose, I mean, we don't have those models yet, but people are trying really hard. It's called meta learning. It's like you learn how to learn and how to pick models. And I mean, there's no reason to start with a model and just use it. You could have a billion different models and use, but that's the problem, that you still need a model to select a model, right? I guess as humans, that's what we do, right? You can't, at the end of the day, it's like you can go a few cycles up and think about your models or the models of the models or the models of the models of the models. But at some point you have to stop and say, okay, that's the best we can do. But I feel like at least in machine learning models, like I'm talking in general, not today's machine learning models, there's less of a limit compared to how humans can do this. So in principle, I think it should do better.
Yeah.
But still, it's important whenever you have a model.
That is the desire.
Sorry, say again.
Oops.
I guess the desire, free will, right? Like that as a person, you choose either you're going to constantly explore and try and find and understand new models of the world, or you just sort of settle into, well, this is what it is, right? And what machine learning can give us is the ability to say, oh, there's actually weakness with this model in this area. I need to go out and try and find a new model. Like, as people, we don't always do a good job of that either. Some people do, not all of us.
So that matches nicely with the Popperian view that science is about disproving theories, right?
Yeah.
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 Okay, so if machine learning, if we gain insights through machine learning that overturn long-held dogma, to use the Wittgenstein sense, then we've learned something, right? We've learned that the dogma is wrong. We can never know that we're right, but in the absence of anything that can prove our model wrong, it's good enough until disproven, I guess, is the Popperian interpretation.
Also relates to another one of the Hofstadter's ideas, right? Like it's the whole idea of self-referencing. Like these models don't have a way to self-reference yet. Like they can't go outside of themselves and look at themselves. But whereas as humans, we do that, right? And that's one of the, I guess, misfirings of language, right? Like if you start writing sentences like this sentence is wrong, then the sentence is referring to itself and it causes all the like logical inconsistencies in Gödel's theorem and all that stuff. So like it's really hard within a system for a system to refer to itself. And I guess we don't have a good way of doing this yet as humans. So I guess we do it naturally, but then there's a limit to how many times you can reference your reference, right? But I think it's like an interesting, you must have studied, Sam, in your computer science courses, something related to this, right? Have you studied like Gödel's theorems and all that?
You basically just can't have stats that contain themselves, right? That just breaks math, so don't do that.
Exactly, but somehow as humans, we do it so naturally that it seems very easy.
Well, we think we do. We don't think about the logical implications of that, right? If we make it very fuzzy, it seems like what we're doing makes sense. But if we think it through, then we realize it doesn't make any sense.
Right, right.
So when we think it through, in my mind, what we're doing is we're hunting for a predicate that proves that everything else is false, right? And as soon as we find a predicate that, as soon as we find essentially a boundary condition that can't be enforced, then we can't create a closed system because there's this exogenous hole over here, and this is Gödel's theorem, and then, you know, anything can get through that hole, so we really can't say anything at all. I don't think this is, I mean, sure, yes, abstractly, yes, but we as humans have dealt with this since the emergence of language just fine. So I'm not saying that language is useless, and this comes through if you read right to the end of the article. And that late in his life, Wittgenstein actually turned from being skeptical to being optimistic and trying to use language in positive ways. So his critique is valid, but let's not throw out the baby with the bathwater, as it were, right? There's still lots of very useful things we can do with language. And once again, if we recognize that we might have to move to a layer of abstraction, like in category theory, that's so high that everything within a category is unlabeled and we can't give them labels, but we can say things about the category of these unlabeled things. And I think that that's where we get into this kind of meta-knowledge and meta-models, of which neural networks, I would argue, is one. I think that when we design these neural structures, we are designing a meta-model. We do give these things labels. That's a fully connected layer, and that's a ReLU layer, and that's a convolutional 2D layer, and so on. So we just have to essentially pick the right level of abstraction that's appropriate for our utility function, if you will, and we're fine. So I think Wittgenstein's critique is fair. I think that so what came to my mind when he was talking about dogma, and this is something that I've looked for in education all my life and never really found, is there's a huge distinction between coming up with a theory of relativity versus being taught the theory of relativity. These are two profoundly different things. And I don't think that the theory of relativity emerged, and I don't know, but I don't think the theory of relativity emerged in Einstein's mind as language. I think he developed that theory as intuition and then attempted to express, and he had troubles expressing with it in mathematics. He actually needed to get help from others to even express his kind of ideas in mathematics itself. But his project was a good one, right? Which is to try and describe these meta-models at a higher level. And I think that's something that language is very powerful at. It's just when we try and drive language all the way down through the meta-models into real world models, we kind of get into trouble because of this predicate problem.
One thing that language does very well is it allows you to make analogies. In fact, most of our words, right, are actually analogies for something else, right? All of our words for abstractions are really just derived from the sort of concrete thing that is an instance of that abstraction. So I think one useful part of language is in sort of an instruction role of linking it to things we already understand.
I mean, you can almost think of it as the essence of intelligence is analogy, right? Like you understand something by knowing about something else and you extrapolate based on the analogies. And that's, I mean, you could, I think, again, I keep saying Hofstadter, I haven't read him in like a decade, but it keeps popping up. But that's his whole program, that intelligence is analogy. The only thing is he couldn't make it work for like real computer models or systems that would learn these analogies. But maybe with GPT-3 or some of these models, we're close, that you could analogies actually ask for it.
That's like an RKHS, right? Like that's all analogies are.
Yeah. I think his favorite example I heard in one of his talks was like he was talking to his niece, like a little girl, and she talked about undressing a banana. And it makes sense for all of us immediately. Nobody has to explain it to you, but it has nothing to do with dress, or it doesn't make sense if you think about it. But for us, it makes perfect sense immediately. So we already have all these sort of links in our heads, or it's generated in a coherent way. So, but we didn't talk about I guess there are. I guess it would have been useful for this article we read to have some more examples of these like simpler cases of failures of language. And like one thing would be like, let's say the word purpose, right? Like I ask you, what is the purpose of a shovel? Then it's a coherent question. You explain it in terms of its function, but then you can use the same word. Like maybe this is what analogy goes wrong, because you can ask the same question about purpose of life. Then maybe it's not really a coherent question. And I think that's what he's saying, that a lot of the profound philosophical questions just go away once you acknowledge that language failed you and it doesn't make sense to ask that question.
Right, which is this idea of trying to establish the boundaries of language, which once again is a bunch of classical conditions which requires language, and blah, 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 and round we go. Oh, we lost Rose, but Yeah, very interesting. Very interesting. Okay.
It's also the Quine thing, right? The inscrutability of language. Did you read this one about the rabbit foot? The title goes like this: you're some sort of anthropologist, right? And you go to a tribe somewhere, and you see a rabbit sort of running past, and someone points at the rabbit and says name, right? How do you know what they're talking about? Are they talking about the rabbit? They're talking about that rabbit? Are they talking about a part of the rabbit? Are they talking about that rabbit in time? Like, you have no way of knowing, right? And in general, we make assumptions and it works out, but there really is no way to know that the language the mapping from language to meaning that you make is the one that people around you intend you to make.
Yeah, I guess you extrapolate based on what would you do in that situation, and when you point at something, you mean the whole thing usually. So then you assume that everybody feels the same way, I guess.
Yeah, I know. I'm reminded of a very funny. I grew up in Australia, and there's a lake nearby, a creek or something, and the literal translation of the name is "It's a creek, you idiot."
Well, I mean, the name of Canada is like that too, right? Canada means a village or something. Somebody that you guys know this story, right? So apparently when the first settlers came and they met this tribe, and so they wanted to know the name of the place, and the guys pointed and say Canada, which means village, and then it became Canada, like the whole country, because they were just saying it's a village, like, and it became the name of Canada. So
exactly. Very good. Okay, so we kind of I mean, I found the article not that great, to be honest. I found there was quite a bit of Wittgenstein fanboy stuff in there, which wasn't particularly interesting to me, about all these scholars who are, writing 4-volume super texts on the work of Wittgenstein. I don't think we should revere him in that sense. I don't think he's a very smart man and everything, and he came up with good conclusions, but I think we've integrated a lot of what he's said into the modern scientific thinking, especially around machine learning with these labelless models. And we're really struggling with trying to reconcile. So is our inability to kind of reconcile and come up with ways of believing in these machine learning models a historical problem, or is it a kind of endemic problem where we'll never be able to trust these models because we can't compress them into our heads? And so,
well, I can give you a very modern problem that people are struggling with, and one of the solutions to it that I saw was, like, at first it sounded really ridiculous to me, but now I'm warming up to it. Like, there's a whole industry of people coming up with explainability for, let's say, neural networks, right? Like, people aren't comfortable that even if you get 90% of the time correct answers, they want to know why it's correct and why it's wrong. So people are like, there's a whole bunch of researchers coming up with explainable models. One of the approaches that I thought was ridiculous, but now I'm like, it's sort of making sense to me, given that book that we read, David, The Enigma of Reason, is, so there's this idea of post hoc explanation. So you run the model, you get an answer, and then there's another model that comes and looks at it, maybe probes a little bit and comes up with a plausible explanation of why the model gave you that. But it has nothing to do with how actually the model came. It's just that somebody who sees the explanation is convinced that that's correct. So at first thought, it looks ridiculous, but that book, Enigma of Reason, argued that's how humans do. Like, you make decisions immediately, and then somebody asks you, why did you do it? You make up a reason that's plausible. Like, it's not, and they do very rigorous experiments to demonstrate that it was not the reason you actually did this. You made up the reason afterwards. So this whole idea of post hoc explanation, I think, is really interesting. And I think people are just being naive, trying to want objectivity out of these models, not realizing that our own models in our heads are totally subjective and not objective at all. So I think there's going to be some reckoning at some point that people realize, I guess, how bad we are, not how bad the models are.
It depends on the field too, right? Like, when it comes to classifying images, sure, we don't expect there to be some sort of reason why it's classified this way or that. But if it's like, you should admit this drug to this, like, when it comes to things where we care more about the outcome not failing.
Sure.
I feel like intuitionistic kind of explanations are not going to cut it. We need some sort of more formal rationale for why this is true or not.
But even for classification, it's not trivial, right? Like people had done, there's this famous experiment on X-ray image, like chest X-rays, right? Like they're trying to classify cancerous versus not. And they had this model that was like really, really good, really highly accurate. So then they look at this data, so you can actually go and see which pixels in the image is the model looking at to make the decision. So you can do that now. And then they saw that there was like a tag, like a doctor's note in the bottom left of the image. And whenever the doctor made a note, it usually meant there was cancer. It was just noting it down. And the model was just looking at that to make the prediction. It wasn't even looking at the whole image. So there's these things that could go wrong. I mean, for classification, I think people are maybe fairly happy, but at least you can see what the model is looking at, like which parts of the image are most influencing the final decision. But that's a simple case. Yeah, but as you said, when you get to like medical decisions, that's I don't think humans can explain things either. So it's just we are demanding something from these models that we can't live up to ourselves either. So
well, we do make simple models in terms of medical stuff, right? It's just that the models are stupid. It's like you know, you just assume that there's some perhaps a couple of things that might be confounders. You measure those and then look at what the result is, and then from there it's all just neural regression. You don't worry about large models because those are something you can't understand. If you don't understand the model, you can't make decisions based on the model.
Okay. But I have a kind of a proposed solution to this quandary, and it is if we could model our own minds, and if we could create agents that had the same limitations that we do as humans, and had all the same foibles based on Tversky's and Kahneman's and all this other very clever work that's going on, and a bunch of other stuff. If we could get a model to be as crappy as we were, but in the same way, I think if we took such a model and then expanded its various different capabilities to beyond human capabilities, but like we gave it a slightly bigger working memory or something, I think we would start to believe that, because it would have within it that which we can comprehend, even if it has capabilities that go beyond our own. It comes from us, and we might be able to essentially accept its insights, right? And it even might be able to come up with post hoc explanations that we can understand. But I think isn't
like probabilistic models an example of this? Like, you know exactly what you put in, like in terms of what connects to what, but then you chunk through the program, you can get results that you can't possibly understand because it gets so complicated. But they're fully explainable, right? Like if you have a
but
probabilistic
if you can create a lens and look at each part of the model, and it is coherent to you in the lensing, even if you can't hold it all in your mind at once, if you can, zoom into all the different parts of the model, and they are, I'm not saying this is perfect, but if we can kind of zoom in anywhere and have a coherent picture that we can understand, but then as soon as we kind of zoom out, it's too much to fit in our head, and then, but if we could zoom in and zoom out like that. Okay, so if I had a causal model that was very strictly understood and a very reliable mathematical framework upon which we could make inference versus a neural network, which would you trust more? Like if there were two opinions on the table, one that was given by some unlabeled black box and one where you could peer inside and see what's going on and what led to that process. It has an explanation, if you will.
It depends, I guess, on the track record of both models. Like if the black box model is 99.99% of the time correct, and the other one is only 80% correct, but it has some explanation for me, I could care less about the explanation. I'll completely I don't care about it. I'll go with the more accurate model, right? I mean, it depends on what you want. Do you want to understand things, or do you want to, like, it goes back to that paper we read, right? To explain or to predict. Like if you care about prediction, then you shouldn't care about explanation as much.
I agree. No, I agree. I think this is.
I mean, there's a limit to that, right? And that's interventions. If you want to be able to predict the result of an intervention, you need to understand the causal mechanism, which is about understanding.
No, you need to have a model, yes. that has that varies with time. Yes, you need to have a time evolution.
Yeah, but is it unthinkable to have a black box model that somehow incorporates every counterfactual that you care about, that it just tells you what would happen if you ask it any question?
That's equivalent to an SCM, right? Which is a model of how things happen.
I guess that would be equivalent. Yeah, fair enough. Yeah.
So Wittgenstein's pretty recent. Like I don't know of any crazy stuff that's happened since then. I've read a bunch of more recent philosophers, like Dennett and so on. Should we explore a little bit of that next? Do we want to kind of keep going? So we did Hume's problem of induction, which I thought was really profound, and I still think that that's an amazing piece of work to this day. We kind of went through the problem of induction, and then we went through all the various different players after that. Do we want to kind of keep this this historical narrative going up to the modern era? Do we want to talk about Dennett and Cog and things like that next? Would that be?
Yeah, I don't mind reading it. I'm not a big fan of Dennett. Like I almost disagree with every single thing he says. I don't know why. Like he somehow managed starting with his free will stuff and all the way to. But I wouldn't mind like reading about free will. So maybe I didn't understand him. So I know Rose mentioned it. She took it for granted that we have free will. I think there is a lot of evidence to the contrary, but yeah, up to you. I don't mind reading Dennett. I don't know much about
Well,
him.
why don't we read a summary of Dennett rather than Dennett himself, right? So I think that the Plato stuff is great because it comes in consumable chunks. I might poke around. I'm very interested in this, this goes back to Kahneman's work on decision theory, right? His new book, Noise, talks about this extensively, where we don't make decisions in logic, right? If we can come up with a testable condition so that there can only be one choice, then you can box system one into giving you the answer that you expect. But decisions aren't made in language. Decisions are made in the soup, if you will, and I'll explain what the soup is to you another time, Sam. But decisions are made by systems that are not directly related to language. Explanations or bad explanations good explanations and bad explanations can either promote or suppress a given intuition. But it is the intuition that is actually making the choice. When you said, if I gave you a black box model versus an explainable model, and you said, well, if the black box model gives better results, then I would choose that one, which is fine, I would too. But the thing that's doing the choosing isn't in language, right? The thing that's doing the choosing is this kind of emotive intuition as that one, right? It's the chicken or the fish question, right? What do I want for dinner? We can't make these decisions rationally. We can say, don't, I'm a vegetarian, so don't eat the meat. That's a testable condition or a predicate. But beyond that, language kind of just stops and we're left with intuition to make the choices that lead us forward. So,
maybe we don't usually, but you can, right? Like there's nothing stopping you from writing logical statements and drawing it on a blackboard of all the decisions, calculating the probabilities, and then going with the highest number, right? It
often goes both ways too, right? Like you often have an intuition first, and then you try and justify it, and that's what math is, right?
Yes.
But that's how research works too, right? You don't start with some sort of formal thing and think through the conclusions of whatever it is that you've thought through. It's you have an intuition about something that might work, and then you go back and test: is this intuition justified in some way? And if it is, then you have the best of both worlds, right?
And if it isn't, then you learned something. Your intuition was wrong, and that's fine, right? Yeah, that's the value that system 2 brings, which is if I come up with an intuition and I come up with a good explanation, perhaps it's not a good intuition, and vice versa. If I have a weak intuition and I come up with a really good explanation, then that will amplify that weak intuition into a stronger kind of proposition, as it were. Great. Okay. Well, I think I'll keep going with the historical kind of arc. Sam, you're very welcome, and we very much would love to see you next time. It's great to have you. And I think we'll bring it to a close here. Does that sound good? Did you have any questions or comments before we close off? No. Okay.
Very nice meeting you, Sam.
Yeah. Well, welcome, Sam. It's great to have you. All right, bye. We'll talk to you on Wednesday. Take care.
Yeah.
Bye, guys.
Take care.
Bye.